Now let's solve logical equivalence problems where we have to prove that two compound propositions are logically equivalent. We'll have to check if they are logically equivalent or not. So we'll have to use a truth table approach for this proposition and this proposition. And then we'll have to see if whatever values we get for this proposition and for this one are same. If they are same, then it is called as logically equivalent. Let's write the truth table, PQ. Let's write all the combinations. So P biconditional Q. Not P, then you'll have not P or Q, not Q, not Q or P. Then we'll have to take this column and use conjunction. So 1 conjunct 2. P biconditional Q. So in this case, both the truth value should be same for it to be true. So here this is true and this is true. Everything else is false. Now this one, not P. Not P is false, false, true, true. Not P or Q. So we'll have to use this column and this column. So this is OR. So one of them, if it is true, it will be true. So this is false, this is true. If false and true is true. Now let's come with not Q. Not Q is false, true, false, true. Now we'll have to take this column and this one. We'll have to OR both of these columns, P and this column. So what do we get? True, true and true is true, false, true. Now the last column, we'll have to AND this one and this one. So for AND, both of the truth value should be same. True, this is false, and this is true. So now this is one column, this is one column. For it, if you see, the truth values of this column and this column is same. That is P biconditional Q and this compound proposition have the same truth values. So let's call this as column 5 and column 6. So both column 5 and 6 are same. So this entire proposition is logically equivalent. So here's another logical equivalence sum where we have to check if it is logically equivalent or not. So we have two compound propositions given here, right? We'll have to check if it is equivalent. Now for that, we'll have to use again the truth table format. Let's, there are three propositions here. So P, Q and R. So we'll have 8 combinations of truth values. Truth, T, T, T. Let's use truth first. P as F, T, F, F, T, F, F. Then repeat the same thing. Let's find Q conditional R and then we'll do P conditional Q conditional R. Then the next column is P conditional Q and P conditional Q conditional R. So let's find Q conditional R. So for conditional truth values, only if there is TF case, that is if the first statement is true and the second statement is false, it is false. Everything else is going to be true. Now let's find TF case between Q and R, right? Between this and R. So here there is T and F. So this is false. Where else do we have? Here again we have false, right? Remaining else is going to be true. Okay. Now let's do P conditional Q conditional R. So we'll have to use this column and this column. So again, let's look for TF combination, TF. So this is false. TT, TT, TT. And so everything else is going to be true. There is no TF here. So it's going to be true. Now let's arrive at P conditional Q. P conditional Q, P and this one. So again, we'll have to look for TF combinations. This is the only one. Third one is false. Fourth one is also false. Everything else is going to be true. Now let's apply conditional on this one and R, these two. right? So again, we'll look for TF combinations. We'll have to take this as the first proposition. So we'll have to look at T's here and F's here. T, yeah, this one, this is false. T's, and there is one, two F's here. Everything else is true. So let's check if they're identical now. We'll have to check this one and this one, these two columns. It is not identical because there are changes here. So both of these columns are not identical. So not logically equivalent.